Okay, part C. So basically, if no one wins the prize in the first week, the grand prize doubles every week. And that's written here. So here it says, write an expression in terms of n for the value of the grand prize in the nth week of the lottery. So the probabilities stay the same, but the grand prize doubles. So what we have the situation we have is the grand prize is $1,000 in the first week, but it's doubling. So you can think of it as a geometric sequence. So for a geometric sequence, u of n is equal to u of 1 times or to the n minus 1, or just u1 or to the n minus 1. They're multiplied. So the first term, the first week, the price is 1,000, or is 2 because it's doubling. So it's times 2 to the power of n minus 1 because he wants it in terms of n. So that's it. That's the answer. And you can just check to make sure you're right. If you sub in 1, do you get 1,000? And you do, because it's 1,000 times 2 to the power of 0, which is 1,000. If you sub in 2, it should double, which it does, because it's 1,000 times 2 to the power of 1, which is 2,000, and then etc., etc. So that's it. That's part C. Not a bad question at all. Part D, it says the Wth week is the first week in which the player is expected to make a profit. Ryan knows that if he buys a lottery ticket in the Wth week, his expected profit is P. Find the value of P. Okay, the expected value is now. So if he plays the lotto, what is he expected to win? So we know the expected return is just this times this plus this times this plus this times this plus this times this plus this times this, but this is now 1,000 times 2 to the power of n minus 1. So the expected value of D is 0, I'll just put 0, plus 2 times 0.1179, plus 10 times 0.03, which is just 0.3, plus 50 times 0.002. Put these guys in brackets if you want, just to make sure you don't make any mistakes. And then plus 1,000 times 2 to the power of n minus 1. And then, this is this times this, because it's the what he'll win times the probability of him winning that. So it's this times 0.00. Let me put a multiplication sign just to be consistent. Multiplied by 0.0001. So this is the expected value of D. Now to solve, I want to find when is this equal to 2, because in order for him to make a profit, remember the tickets cost $2, so to make a profit the expected value has to be more than 2. So I'm going to find when is it equal to, and then it'll be the week after that. Now I've already done this, guys, so let me just go back and show you how I did it. Okay, so I graphed this, the expected value. I typed in literally what I wrote down here, including, you can see, 1,000 times 2 to the power of x minus 1. Now use x when you're graphing, and this is times 0.0001. It's actually just changed it to that, but that is e minus 4 is 0.0001 in calculator language. So that's my blue graph, and then my red graph is just 2. And I'm going to find where they intersect. And, well, I'll delete that and do it again. The way I found where they intersect is analyze graph, intersection, lower bound, upper bound, and I get this 4.77, 2. So the solution to this is n equals 4.77. Therefore, if n is 4.77, if we go back to the graph, which week, what's W is the question. Well, you can't have the 4.77th week. It's either the fourth week or the fifth week. Now, if it was the fourth week, which is here, and I can go menu, trace, graph trace. Now I can actually, I can type in 4. That gives me the fourth week. If I go to the fourth week, the expected value is less than 2. But if I go to the fifth week, the expected value is more than 2, and it's 2.2358. So I can say, therefore, W has to equal 5. And when W equals 5, the expected value of D equals this, 2.2358. 2.2358. So 2.2358. And then finally, I'll do another therefore. Therefore, P has to equal this minus 2. 2.2358 minus 2, because this is the expected value. This is what we expect to get back. But it cost $2 to play, and the question said his expected profit is $P. So if the profit is $P, what's his profit? Well, the profit that he's expected to make is then 0.2358 dollars, if you like. Now you may say, well, should I round it here? No, because it's more importantly, because the start of the question said, make sure that you round all your answers to 4 significant figures. So that's actually what I'm going to round to, 0.2358. In fact, I was just going to make sure that it was rounded correctly, but that's fine. Okay, that's it. That's the last question of the paper. I think actually that wasn't, considering that the last long questions are usually the hardest questions in the paper, I don't think that was that bad. It wasn't easy for sure, but not too bad a question. Okay, that's the paper, guys. I'll see you in the next video.